Assalamu alaikum guys, welcome back my channel. Today we have again the continuation and discussion related to the our previous topic that I was started in my previous video and online lecture, that was related to the concept of vector space. And that topic actually I started because it is very useful, particularly in the field of economics. And in the my last video, I just recall, I want to recall you why I selected this topic, because normally there is misconception and the understanding related to this topic that it is especially designed only for the field of physics. But now you have multiple, you have use of this topic in multiple areas, like in the computer science and in the robotic and the machine language, in the data science, as well as in the field of economics. Today we are focused towards related to the field of economics, and we will discuss in detail of this topic. Okay, first of all, I just want to list down that what area I will cover in this lecture related to the vector space, and how, and I will try to relate this topic with my area, that is actually the advanced microeconomics. Because whenever you are reading the literature of advanced microeconomics or the econometrics and something else, so you and the mathematical economics especially, so you have this kind of topic, and there are detailed discussions in the mathematical economics books related to this topic. So that's why I have selected this topic for you, because if you are able to understand and you have understanding related about this topic, so inshallah, hopefully you can easily understand the language of this book or these literature. Or particularly whenever we talk, we have reading related to the advanced research article in different reputable journals, so you have the use and the entire discussions that is basically based on the concept of the vector space, not specific, but they use these language and these concept in their debate and their arguments or in their literature review. So that's why I'm focusing towards this topic. So, guys, let's start. What the topic is based and what we have covered in previous lecture. Just recall you. We have covered here. We have discussed what? Yes. What we have discussed, we discussed start group. Okay. Second concept, we start definition of abelian group. Okay. And third one, we start the concept of ring. Okay. Finally, we move towards the field. Okay. So in the last video, I completed my lecture related to the topic of field, and that was the sequence of the vector space topic that started from the group, abelian group, ring, and the field. Okay, and we have covered in my previous lecture. Okay, now we are moving forward towards the topic of the vector space, and what are the basic assumption of the vector space. Space means ke area in the entire field or area in different dimensions. It is basically the vector space, or the it is why we called it vector space. There are certain important assumptions or the axioms related to that area or that space. Okay, and what are that assumptions here? First of all, uh, okay, but one important thing. Before starting the discussion related to the vector space, I just want to point out to you uh, the topic of topics for discussion. Okay, topics for discussions are, okay, what are the topic for discussion? First of all, we will discuss number one, vector space, vector space on the basis of certain assumptions. Okay, okay. What I'm going to list down the topic of the vector space because it is very detailed discussions, particularly in engineering and the mathematics, the field of the mathematics, or because it is this topic is related to the linear algebra, and there is entire you have an entire course of linear algebra, but it is not the part of our discussions because we have to select the certain important topic that are useful because we are I am not teaching you the course of mathematics here. I am teaching the course of advanced micro, so that's why I have selected some important topics that will I find, maybe I am wrong, I find that these are useful topics for you, that you should know about these concepts. Okay, so number one is, number two is, okay, when we decide कि space is a vector space, area space or area is a vector space, so on the basis of the certain assumptions, then we will move the another topic of vector space is linear combination. Linear combination. Okay, I will discuss in detail what is actually the linear combination. Second important thing is that, okay, uh, convex combination, in vector space. Sorry, first of all, convex set in convex set convex set in vector space. Fourth one is convex combination in vector space. Okay, yeah. Fifth one is uh, span. Okay, span of linear span and subspace of vector space. And the sixth one is very important topic: the independent and linearly dependent. Okay, linearly independent, L I, and linearly dependent, LD. Okay, so these are six important topics which you need to discuss in the field of vector space, particularly uh, for the student of economics. Okay, so you should know about these topic, and I will try to relate all the concept with our area, our objective, that is actually the microeconomics, advanced microeconomics. Okay, so I will try to relate all the concept with that area. So first of all, I just starting the one important concept or the definition of the vector space on the basis of these ones. So first of all, I am selecting this one. Okay. So vector space on the basis of the certain assumption. Now the vector space. Okay. I am writing this F. Okay. And plus and dot. Right? Yeah. What does it means? The vector space defined over the field of real number. Okay, and when we talk about the field of real number, so ultimately every field has two important operations. These are called the binary operations, addition and multiplications. Okay, so it means कि vector space defined over the field of real number, and that field is yani there are two important operations. Those are called binary operations. These binary operations are applicable in the field of real number. And why we talk about the field of the real number? One important thing is that because we our focus is towards only the one important thing. That important thing is that we don't know. For example, we don't know, yeah, we don't have the discussion related to the complex number or the rational number here. Our discussion is just based on the concept of the real number, particularly for the as a student of or the for the student of economics here. Okay, so that's why I'm starting here. Just a minute. Yeah, yeah, just a minute. Okay, so now, so first of all, the topic is the field. I have defined that it is the positive numbers or real numbers. So about the field, we have discussed that it should satisfy certain assumptions that are associative property, commutative property, and there is existence of identity, additive identity, and there is existence of inverse. Okay, so these are some important properties related to the field. Whenever we talk about the positive and multiplications, so we understood that there are two there is one associative law is here, associative law with respect to addition and with respect to multiplication, as well as you will have a commutative law with respect to addition there. And similarly there is additive identity which is called zero, and there is inverse of vectors, that is with respect to the multiplications, clear, or with respect to addition as well. Clear? So now these are certain important properties which we have discussed in my previous lectures related to the field. Now we are moving forward here. Clear? So now consider the n-type real number. Now consider n-type real n-type set of real numbers and element, okay, and elements, set of n-type real numbers and elements. Clear? Those defined over the field of those defined those defined over the field of real numbers. Okay, over the field of real number, it will it is called vector space. It is called vector space. Clear? So it is called, yani that is basically we can write V is a field of positive and dot. It is called it is called vector space number one, addition. Okay. So it is called vector space that with respect to addition, it satisfies certain properties. What are the properties? Associative law, number one, associative law, that is x plus y plus z equal to x plus y plus z, right? And all x, y, z belongs to V, vector space. You got my point? Okay. So that is associative law. And second one is commutative law. Commutative law. What is the commutative law? Okay. The commutative law is x plus y equal to y plus x. All values of x, y belongs to V. Yeah, vector space. So it is commutative law. Second one is now what? There is existence of identity, that is theta, and theta equal to 0. It is called additive identity. Additive, okay. There is existence of theta, and that is theta equal to 0. Clear? It is called additive identity. Okay. And third one is the uh, inverse, additive inverse. So implies that 0 plus, yeah, theta. So x plus theta equal to x, which belongs to v. Okay. Now, uh, additive inverse. Yes. What is additive inverse? There is existence of there is existence of inverse. There is existence of inverse. Clear? Existence of inverse that x belongs to v. So x plus minus x equal to 0, and 0 belongs to v as well. Okay, so it is additive inverse. Now we have to satisfy these axioms with respect to additions: associative law, commutative law, additive identity, and additive inverse. Okay, I will relate these topic with respect to the economic theory as well in detail after few minutes. Okay, first of all, I just complete the other axioms or assumptions related to the dot or multiplications. Okay, with respect to additions, I have covered. Yeah, I have to prove these properties to justify the vector or to prove the vector space. And similarly, in case of with respect to the dot, I need to further satisfy certain axioms. When we will complete all the axiom with respect to the addition as well as with respect to the dot, then we can recall or we can say that it is that space is considered as vector space. Okay, you got my points, so move forward. Okay, and I know that actually it is also called the closure property. Okay, closure property with respect to addition and with respect to the multiplication as well. And now with respect to the multiplication or the scalar multiplication. Scalar multiplication. Okay, yeah, with respect to the scalar multiplications, we can say that uh, alpha x, okay, or alpha beta into x equal to number one, what, alpha beta x. What does it mean? Look at this one. This is associative law with respect to addition. Okay, similarly it is associative law with respect to multiplications. I can recall it: associative law with respect to multiplication. Okay, associative law with respect to multiplications. And now third one is what? The third one is the identity or multiplicative identity. The third one is multiplicative identity. Multiplicative identity. Yes. Okay. What about the multiplicative identity? 1 dot x equal to x and all x belongs to V. Okay. So there should be the property of the multiplicative identity, and 1 belongs to and 1 belongs to field. Okay. The 1 belongs to field. It is an scalar quantity that belongs to the field. And what about zero element, existence of the zero? Okay, so existence of existence of zero vector. Okay, what does it means? 0 dot x, that is equal to theta, and theta and x belongs to V. Okay, so this is zero, existence of zero vector as well. Okay, now existence of zero vectors. Now the last one is the distributive law. The distributive law. What about the distributive law? Distributive law. Okay. So distributive law is alpha beta into x equal to what? Alpha x, alpha x plus beta x, and x belongs to V and alpha beta belongs to field. Okay, x belongs to V and alpha beta belongs to field. So that is the distributive law. So now just recall, you need to satisfy these assumptions or the laws with respect to the multiplicative scalar multiplications and with respect to the additions. So when you satisfy these property, so we called it is a vector. That space is considered as vector space. Okay, so now uh, one important technical concept that is related to the our topic of economics as well, that you need to discuss in that area before starting the detail of that vector space. What is that topic is internal and external composition, and I will relate that internal and external composition with our microeconomic theory or the advanced microeconomics theory. Then you will understand how these axioms are important and why we relate and how we relate these axioms with respect to the theory of microeconomics or the microeconomic theory here. So first of all, one important topics in that area, when you have decided now the space is a vector space, so that vector space has two important composition. Every vector space has two important composition. One is called internal composition and another one is called the external composition. Clear? So now move towards these compositions. Okay. Okay, internal and external composition. Okay, you got my point? Yeah. So internal and external composition. Okay, internal and external composition. Yeah, it is very important topic for discussions. Is what is that? Okay, for example, there are, assume here we have two set of vectors. Okay, A and B. Assume here two set of vectors. Okay, A and B. Okay, and we call it, for example, A is defined over the operation of addition. Clear? A is defined over the operation of addition, and set B is defined over the operation of addition plus multiplications. Okay, so now we call it A is defined over the operation of addition and is defined, okay, is defined, okay, is defined over the operations of addition as well as multiplications. Addition as well as multiplication. Okay, and so ultimately, what we can say that, we can say that k, for example, A is a set of alpha and alpha, beta, and gamma, alpha, beta, and gamma. Okay, vectors. Okay, and B is a set of A and B that belongs to field. Okay, and field of real number. What does it means if we add select any two elements within A? If we select any two elements within vector set A, these all are the vectors, vector alpha, vector beta, vector gamma, and these are some scalar quantities, yani 1 2 3 4 5 6 7 8 9, any one. Okay, so A and B are some scalar numbers that belongs to field F. Clear? So now if, acha, assume here two sets in a vectors, in a vector space. Just let me correct. Assume here two sets in a vector space A and B. Okay, A defined over the operation of addition, B defined with addition as well as with multiplications. And now we assume that case set A is the element of vectors alpha, beta and gamma, and set B is the element of scalar numbers A and B. Clear? Now when we select any two vectors elements from set A and we apply addition, operation of addition on that set A, and that set A is a part of this, yani that after addition you will get again another element of this set A. So we can say that A is defined over the operation of addition. Okay, or A has internal composition with respect to addition. Okay, A has internal composition with respect to addition. What I told you set A, yani we defined two sets. Okay, two sets in a space. Okay, whatever the space is here. For example, this is space, right? Any space in the any geometrical shape, circular shape, or in the rectangular shape, in the triangular shape, we have a space. Okay, and we select, okay, for example, A is element of alpha, beta and gamma. Okay, in that. Okay, and we defined with respect to additions, and similarly B is another set of here which belongs to this one. Okay, it is what belongs to vector, and this is belongs to R, sorry, field. Okay, recall it what I told you, that space cannot define until and unless you define a field. Remember, I told you first of all you have to define a field, and that field should have two important operations. What are the two binary operations? These two binary operations are applicable in that field, which is addition and multiplication. So I select, so ultimately when you can apply two binary operations in the field, so it means that you required a certain numeric numbers. These numeric number will relate or are related to the real number sets. Okay, so I told you that numeric numbers are related to the set of real number. And what are the set of real numbers? Set of real numbers are here A and B. So in that space, to define this vector to space or to define these element of the vector, we required this scalar number as well. Okay, so it means that vector space consists of two sets. Okay, two set. One set is related to the field, on which field you define these vector elements. Another one is the elements of the vectors are here. Okay, so in that condition I told you, okay, when it will called the internal composition is here, I called it the internal compositions. When we select any two elements of the vector, and we add these two elements and get the another element or answer, and that answer should belongs to this set A. So we called it the set A is has internal composition with respect to or over addition, has internal composition over additions. Okay, so what I told, okay, select any two elements of vectors from set A, that is alpha and beta. Apply addition. Okay, so alpha plus beta, okay, and equals to, for example, gamma, and that belongs to set A, and set A belongs to vector. Okay, so what does it means? I can say that A has internal composition over has internal composition over has internal composition over addition. Okay, has internal composition over addition. Yeah, so it is the internal composition. Okay, internal composition over addition. Now, what about the external composition? External composition is that when we multiply, okay, when we select one element from set A and another element from set B and get the answer of set A, clear, get the answer of set A, so it means कि we can say that कि x means कि we can say that कि it has external composition, it has external composition with respect to multiplication. It has external composition with respect to multiplication. So it means with respect to addition has internal compositions. Now select, I just going to rub it. Okay, select one element of vector, that is alpha. Okay, one element of vector, that is alpha, and now and a scalar number from set B. Okay, set B, alpha dot, sorry, yeah, a dot alpha equals to beta, that belongs to set A, which is belongs to vector. Clear? So I can say that all alpha belongs to V and A belongs to F. Clear? A belongs to F. So we can say that A has external composition. A has external composition, external composition with respect to multiplication or over multiplication. Over multiplication. Over multiplications. Okay? External composition over multiplications. That was the correct. Okay. What does it means? One important thing is here. So, first of all, we have covered the external multiplications, external composition as well as internal compositions. And now, recall the concept of, for example, internal compositions, recall the concept of the convex combinations in microeconomics theory. When we talk about the feasible sets, okay, when we talk about, now I am relating this concept, these two important compositions with respect to my area of discussions, that is advanced microeconomics. Okay, why? Because ultimately you people may have a questions case, why sir you are going to discuss, why we are discussing this topic here, because it is detailed discussion of linear algebra. Those are especially designed for the student of mathematics or student of engineers. So why should we discuss here? So now there is important to discuss this topic or to define the internal and external compositions, because when we discuss the feasible choice set, okay, and feasible choice set means ke choice variable. So choice variables, we assume that ke these are the feasible sets. So feasible sets में one important property is the convex sets. You recall it, okay? Because you can check it yourself in any advanced microeconomic literature in the appendix of Grewal and Rees, or in the discussions of the consumption sets in the masculine, Andrea and masculine, you can have a discussion related to the convex set or choice variable or the feasible sets. So one important property of the feasible sets is the convex sets. So convex sets you cannot define the without discussions of the convex combinations. Okay, so that's why I told you